Hello, dear students. Welcome to the third episode on atomic structure, wherein we are going to continue our discussion regarding the strategy NEET of this year, containing most likely questions from this chapter. Let's begin. Here is a beautiful question for us. The mass of electron is 9.11 into 10 to the power minus 31 kg. This we already know. This is the mass of electron. And Planck's constant is 6.626 into 10 to the power minus 34 joules. This value also we know. So let's see what we need to find out. The uncertainty involved in the measurement of velocity within a distance of 0.1 angstrom is. So we are supposed to find out uncertainty involved in the measurement of velocity. So that means this numerical is purely based on Heisenberg's uncertainty principle. So let's see the different options given to us. Option A, 5.79 into 10 to the power 6 meter per second. Option B, 5.79 into 10 to the power 8 meters per second. Option C, 5.79 into 10 to the power 7 meters per second. Option D, 5.79 into 10 to the power 5 meters per second. Here, dear student, you need to be very careful. Look at these options. Options are all having the same value excepting for the value of powers of 10. So when this being the case, you need to be very careful when you are doing the calculation regarding the powers, because most of the time in that examination tension, many of you will tend to make a mistake when you are doing it with the powers. So you need to be very careful when you are solving such type of numericals. Okay, let's see which one is the correct answer. Correct answer is option A, 5.79 into 10 to the power 6 meters per second. Now let's see why is this the correct answer. Now, as I already told you, this numerical is based on Heisenberg's uncertainty principle. So what is the mathematical form of Heisenberg's uncertainty principle? Delta x, that is error in calculating the momentum, into delta v, that is error in calculating the velocity, greater or equal to h by 4 pi me, where me means mass of electron. So let's substitute all the values. Here I have substituted all the values just to give you a clear idea. In the examination directly you can come to this step for solving and then continue with your calculation. So now just to make you to understand, I am using all of this in a detailed fashion. Okay, delta x, that is error in calculating the momentum. So therefore that will be 0.1 angstroms. So you know that 0.1 angstrom is nothing but 0.1 into 10 to the power minus 10 meter. Angstrom is 10 to the power minus 10 meter. And we know the mass of electron. Even if they have not given this value, you should be remembering this value. And what is the mass of electron? 9.11 into 10 to the power minus 31 kg. And the value of h, that is Planck's constant, is 6.626 into 10 to the power minus 34 joule second. And you know the value of pi, which is 3.14. And let's put this value according to this formula written here. So delta v we do not know, we know delta x. So that is 0.1 into 10 to the power minus 10 meter will be equal to h value, that is 6.626 into 10 to the power minus 34 joule second. 4 value as it is, and pi value is 3.14, and that of mass of electron is 9.11 into 10 to the power minus 31 kg. Because we have taken the value of delta x here, so if you are equating it to delta v, so delta x will come to the denominator. So now entire thing is going to be the same. Along with this, you're going to take this delta x value down, which I have written here. So on simplifying this, you're going to get the value as 0.579 into 10 to the power 7. And when you shift the decimal to the right, you're going to decrease the value of 1 power of the 10. So that is going to be 10 to the power 6. So you need to be very careful. Again, I want to stress on this point because all the options are having this as our main value, but the power of 10 is going to make a lot of difference, because you know that each question carries 4 marks. You cannot afford to make a small mistake like this and then lose that marks, and also you'll be getting a negative mark correction for this. So be very careful when such type of options have been given as the numerical to you. Okay, hope you got this. So let's proceed with the next type numerical. You know this option A is the correct answer. Let's proceed. So second question. The energy of second Bohr orbit of hydrogen atom is minus 328 kilojoule per mole. So second Bohr orbit of hydrogen atom energy is given to us as minus 328 kilojoule per mole. Hence, the energy of the fourth Bohr orbit would be, so they want us to calculate the fourth orbit energy in a Bohr's model of atom. So let's see the different options. Option A, minus 41 kilojoule per mole. Option B, minus 1312 kilojoule per mole. Option C, minus 164 kilojoule per mole. Option D, minus 82 kilojoule per mole. So now let's see which one is the correct answer. Correct answer is option D, minus 82 kilojoule per mole. Now let's look into the fact why is this the answer. So let's write down the data given to us. Again, I would like to stress on the point, all this detailed explanation is being given to make you to understand the method of solving the numerical. In the exam, you need not have time to do all of this. Just directly come to the final step, and that will save you a lot of time. I'm just giving you the line of thinking and how exactly you can proceed. That's it. Okay. The energy of the second Bohr orbit of the hydrogen atom, that is second energy E2, is given to us as minus 328 kilojoule per mole. And how is that we got this minus 328 kilojoule per mole is by using this formula. That means this is a formula that we can use for calculating the energy of any orbit. N is any orbit, nth orbit in a Bohr's model of atom, and this will be En will be equal to minus 1312 divided by n square. N indicates the number of orbit from the nucleus, and the unit of expression is kilojoule per mole. So now this value is given to us as, if you calculate this, you will get the value as minus 328 kilojoule per mole. Minus 328 kilojoule is the value of E2 that is given to us. In a similar way, what they want us to find out is the energy of the fourth orbit. So directly we put the value of n as 4 and then we can proceed with the calculation. E4 is equal to minus 1312 divided by 4 square, that's going to be 16. So 1112 divided by 4 square is going to give us the value as minus 82 kilojoule per mole, because this minus remains as it is. So you know this option D had this number as minus 82 kilojoule per mole. So that's the correct answer. Hope you followed. Keep watching all of the episodes and then keep learning and keep improvising your scores. I wish you all the best. In the next set of videos, I would like to give you some idea regarding the exact topics that are there introduced for this year NEET examination. Okay, once again I wish you all the best.